Good afternoon, my YouTube viewers. This is Crystal. I'm here to make another video for you, and I haven't made a video in a few days because I've been busy doing other things. But this is a video on Kaggle's Playground, Season 4, Episode 7, and basically um, what I've done is I did a Jupyter notebook and I saved it onto my account. And what I will do is when I make the video, I will leave a link to it um, on the video so you can look at the Jupyter notebook if you want to. And basically what I've done is tried three different models out. One model I tried was TensorFlow, but the class weights wouldn't work. And because the class weights wouldn't work, I couldn't balance the class weights. And so I got a higher accuracy, but that's because the class weights wouldn't balance. I also tried it on extra trees because tree-based models are supposed to be really good with an imbalanced class. And because of that, um, because of that, um, I couldn't do it. The Kaggle just crashed on me. So I'm using logistic regression. And when I had logistic regression, I got 82% accuracy, which wasn't as much as when I was using TensorFlow. But because I was able to balance the classes, then I think it worked out better, which is why that's what I'm using. So we're going to start with the problem statement. The problem statement is predict on the probability of insurance cross-selling. And I think cross-selling is when you're able to sell another product to a customer. And that's what I believe cross-selling is. But when I do the blog post, I'll look it up some more. And then after we looked at our problem statement, then what we're going to do is we're going to import the libraries. So we're going to import NumPy as MP to make numerical computations and make NumPy arrays. We're going to import pandas to make data frames and process the data. We're going to import OS to go into the operating system. We're going to import SciPy to make scientific computations. We're going to import sklearn to provide machine learning functionality. We're going to import matplotlib, .pyplot SPLT to visualize the data, and then we're also going to import Seaborn to visualize the data. So those are the libraries that we're going to be importing into the program to make the program work. So then we're going to use OS to go into the operating system and retrieve the files. And we've got 3 CSV files being train, test, and sample submission. Then what we're going to do is we're going to use pandas to read the files and convert them to data frames, and it's going to be train, test, and submission. So you can look at train. You've got 12 columns of data, the last column being response, and so that's your target. So we checked for null values. We didn't have any null values, so I didn't have anything to impute. We checked test, and test has the same format as train, with the exception that it doesn't have a target because that's what we're predicting on. We checked for null values on test, and we don't have any null values, so that's good. This is submission. This is what Kaggle wants to see when we submit our work, and we're going to be making a probability. So rather than predicting on a 1 or a 0, we're going to be predicting on a probability. We're going to analyze the train and the test set. So we're going to check for the number of unique values for each column of data, so you can see that. And then we're doing that with test as well. And then what we're going to do is we're going to drop the column that says ID because you don't need it. The reason why is because Pandas automatically indexes each row of data anyway, so you don't need the ID. So I just took that out. Okay, the next thing we're going to do, this is the code to make a lovely little diagram of ones and zeros, but it just took too long to do it because you had like 11 million, you had like 7 million rows of data in the train set, and that was just too much. So I couldn't do it. It was taking too long. But there's the code if you want to use it on another data set that isn't so big. We're going to define the variable target, which is we're going to pop response out of the train set. And so this is something that I did just to balance the weights because it's really difficult to balance the weights using sklearn because sklearn does have a class weights model, but they don't tell you how to use it. So then you have to try to figure out how to use it. So I did some research on the internet and I found the formula to balance the class weights. And I did this in a very simple fashion. But what I did was I have a medium account and then I jazzed it up in my medium account. First thing I did was I used a for loop and then I created a function. But this is just very simple how to balance it. If you want to know very simply how to balance the weights, the class weights. And so there's the code right there that you can look at. And I will give you a link to this page. Now we're going to create a histogram so you can see we've got imbalanced classes. And because the classes are imbalanced, they need to be balanced. So now this is the Kolmogorov-Smirnov test, but I decided in the end not to use it. And the reason why is because I only had 10 columns of data total that I was going to be using. And so it was only 10 columns of data, so I decided not to use it. But there's the code there if you want to use it. So now what we're going to do is we're going to encode all of the columns that are object columns. And then when we code it in the train and the test, so this is your train, and you can see that instead of having strings, you've got numbers. And it's the same for the test as well. So now we're going to use Seaborn to create a heat map. And this is the code right here to create your heat map. And you can see that the columns of data are not very highly correlated. And so because the columns of data are not very highly correlated, and there's not that many columns of data anyway, I decided not to delete the highly correlated columns. But you can see the correlation here if you want to, and that'll show you that the columns of data are not very highly correlated. Now what we're going to do is we're going to define our x and our y variables. So your y is your target, which is a variable that's already been defined. X is train, and x test is test. So now what we're going to do is we're going to set our class weights using sklearn. So this is a way that you can balance your class weights using sklearn. And then so I showed you 2 ways to do this in the program. And then if you compare the class weights to sklearn with the class weights to the little bit of code that I made, you'll see that it's the same, but I just wanted to compare sklearn to the code that I made just to make sure that I was getting it right. Personally, I prefer the way I did it better because you only need one input, which is Y, and you don't need to do anything else. And I did a blog post on how to do that in a function in Medium Publications. Now what we're going to do is we're going to normalize the data. We're going to take everything in X and X test, and we're going to convert all the values to level between 0 and 1 to normalize it. And then when you normalize it, you don't normally have to normalize it with logistic regression, but what I would do is I would try it with normalize, and then I would try it without normalize, and then the one that gives you the most accurate reading, that's the one that you should be using. And then what we're going to do after we've normalized the data, we're going to split the data. We're going to use sklearn train test split to split the data into training and validation sets, which we have done here. And now we're going to define our model using logistic regression, using random state equals 42, C equals 1, and class weight equals class weights. And we had a 64% accuracy, which wasn't that great, but I couldn't get the tree-based model to work because there were just so many examples. Now we're going to predict on the validation set, and you see you have a bunch of ones and zeros, and then you have a 64% accuracy when you predict on the validation set. And now we set up a confusion matrix to find out how many ones and zeros we've got, how many false positives and false negatives we've got. So you can see it that way. Now I just created a data frame so you can check the actual values against the predicted values. Now we're going to predict on the test set, and since we're predicting on probabilities rather than the predict method, or we're going to use the predict proba method. And then after we've predicted on the test set, we're going to prepare our data to be submitted. So the probability is going to go into the response column of the submission column, and then we're going to convert that to a CSV file, and then we're going to read the CSV file, and this is the output that we have when we have read the CSV file. And then we save our work, and when we save our work, we submit it to Kaggle, and when I submitted it to Kaggle, I got 82% accuracy. And so this isn't TF. I know it says it's TF, but it's not TF. I was just experimenting with lots of different models, and I forgot to take the TF out. But it's sklearn's logistic regression. So that's it for this code. And what I'm going to do is I'm going to leave a link to the Jupyter notebook for you, so you can look at the code yourself if you want to. So I'm going to conclude this video. If you like my video, please like, subscribe, and share. And I look forward to communicating with you in the next video.